In our previous video, we looked at the process for finding the magic number, the value of c that would make a perfect square trinomial. Let's go ahead and use that step now to actually complete the square in order to solve one of these equations. So first thing first, we're going to do two videos. One video where a is equal to 1. We'll do a separate video where a is not 1. So in this case, our a value, our coefficient of x squared, is 1. You always want to start the problem not by being equal to 0 like we've often done in the past, but we're going to start this by separating our x terms from our constant terms. So I'm going to take that negative 4, or that 4, and subtract it to move it to the other side. So that's how I'm going to begin the completing the square method. Now is the part where we're going to find our magic number. So our magic number is to take our b value, remember, and divide it by 2, and then square it. And there was a reason we wrote out the work. Negative 12 divided by 2 is negative 6. And negative 6 squared gets you 36. Remember, the magic number will always be positive because of those parentheses. And so what I'm going to do is I'm going to add that to my trinomial side, because that's the magic number that allows us to factor. But I can't just add a number to one side. I've got to make sure I add that same amount to both sides to keep my scale balanced. So make sure you add the magic number to both sides. If you remember, the reason we've been calling it the magic number is I'm now able to factor the left side of this equation. I need two numbers that multiply to 36 and at the same time add up to negative 12. Well, I know that's negative 6 times itself, which, remember, is that number we had right there. So I factor this into x minus 6 squared, since there's x minus 6 times x minus 6. Hence, that's where the name completing the square comes from. And on the other side of my equation, just add those values together. Negative 4 plus 36 is 32. And what we've done now is we've written an equation that we've actually solved in the past. We've done these problems, so I now have a method for solving this. So at this point, we'll do what we've done before and take the square root of both sides. And so I'm left with x minus 6 is equal to, there's still two answers, so plus or minus the square root of 32. No imaginary numbers because I'm taking the square root of something positive, but I still need x by itself, so I'm going to go ahead and add that 6 to the other side and say 6, it's positive 6 once I've moved it over, and then plus or minus the square root of 32. Well, as always though, we need to simplify our square roots, so let's break down 32 into, I don't know, let's say 8 and 4, I suppose. And keep factoring that down until they get prime. So 4 breaks down to 2 and 2. 8 breaks down to 4 and 2. So you get a whole bunch of 2's in this problem. Find all your pairs. Your pairs get to be taken out of the square root. So my final answer when I'm done with this is going to be 6 plus or minus. We have a 2 times 2 that comes out, so a 4 out front, and then that single 2 left over. So that is the equation, or the answer to this equation using the completing the square method. If you want to try the next one on your own, go ahead and pause the video and I'll work through it if you want to check it afterwards. Otherwise, watch this one because this time the b value is an odd number. So watch how this is slightly different. We're going to have to work with fractions, but so be it. So if you're pausing and trying on your own, go ahead and pause it. Otherwise, let's try this one. A is still 1. So I started out by grouping my x terms on one side and my constants on the other side. So I'll add the 2 over and get a positive 5 on the other side. I need to find the magic number, and remember, we add it to both sides to keep the equation balanced. So let's take half of our b value and square it. Now, unfortunately, our b value is odd, so we're not actually going to get a decimal. I'm going to leave it as a fraction and square it, giving me positive 81, 9 times 9, over 4. As my magic number, 2 times 2. So that's the number I need to add to both sides. So 81 over 4 and 81 over 4 to keep my equation balanced. Now, I may not know how to factor this left-hand side. I don't know what numbers multiply to 81 over 4 and add up to 9, but remember the trick, whatever that b value was after we divided by 2 but before we squared it is what this will factor into. So it's x plus 9 halves. That sign will always match the b value sign squared. On the other side, I need to add these two values together. Well, that's going to take a common denominator. I don't want to go into that right now. That's another topic for another day. So I'm just going to use my calculator and add 5 to 81 over 4 and come up with 101 over 4. If you don't know where I got that, again, I would need a common denominator or just use a calculator. Okay, so again, leave it as a fraction though, no decimals. So now it looks like a problem we've done before. I'm going to take the square root of both sides, and when I take a square root of a fraction, it's really the square root of the top over the square root of the bottom. So my square roots cancel out. I've got x plus 9 halves is equal to, now the square root of 101 cannot be simplified. That's a prime number, so I'm going to put my plus or minus sign as always, and then leave the square root of 101, but in my denominator, the square root of 4 is just a regular 2. That's why I did not want to change this into decimals. I can stick with fractions, and I should have denominators that simplify pretty easily. My last step then to finish this problem to get x by itself, I need to subtract that 9 halves. So I'll subtract 9/2 from both sides and write that number down in front. So negative 9/2 plus or minus the square root of 101 over 2. Our answers definitely are looking nastier and nastier, but that's what they look like when we complete the square. Now, if you wanted to, because I do see a common denominator, if you really wanted to, we could combine those into a single fraction, since we have that common denominator, and write negative 9 plus or minus the square root of 101 as the numerator, and just divide that by 2. That's not necessary, but if you want to do it, that's totally fine to do.